Hi, my name is Sergeant Ross. I'm the CEO and founder of Savicorp. This is our corporate facility here in Santa Ana, and I'm going to give you a tour of every stage of the process of what we do here. This is the staging area. This room here is a staging area where we bring vehicles in, we check original parameters anywhere from the way the engine runs, all the hoses and all to make sure that everything is running properly, and we also do emission testing and we document all the OEM parameters, which means original equipment manufacturer's parameters. Next we're going to go to another room and I'll explain what we do in that following room. In this room here we put the dyno valve kits together. They're manufactured outside. We bring them in here and then we actually package them here, warehousing them here. And we also have a special R&D room. We have mechanics. To my right here, there's the workbenches where the mechanics work out of, and also we do small prototype R&D. Behind me, there's some cubicles, and half the cubicles we do the CAD work. So once we finalize the product, we completely do a set of blueprints. They're all electronically done, and then we also do quality control, schematic diagrams, and also any type of prototyping that has to be done for any type of new vehicle or new system that we might build. Like if we want to put it on a Harley, we would bring a Harley in and retrofit it, blueprint it, and then have a kit ready and available for it. In this room, we do retrofits. We have a new product we're going to be introducing pretty soon. We did introduce it in the open house, but it's not going to be introduced to the public for probably a few weeks. We'll let you know as soon as we're ready to. So we do those retrofitting kits. We're getting certification on that product. But behind us, you see 4 lifts, and those lifts are made for installing dyno valves. We also do auto repair here because some of the vehicles that come in for an installation might have inadequate hoses or wires, and we have to fix them before we can actually install the dyno valve. Behind me, all the way to the wall, is a machine shop, small machine shop. It allows us to make small parts, fabricate small things that we need to do these retrofits. This is a dyno room. In here we have dynos. We have 3 different types of dynos here. We have one to my right, which is for older vehicles, 2000 and older. The one to the left is for newer vehicles, and the one in the middle is for motorcycles. There's a room behind me which is a Hariba equipment, which controls the dynos. What these dynos do is when we do 3 baseline tests with the vehicle that we want to certify, or a class of vehicles we want to certify, we'll put the vehicle on a dyno, we'll do 3 baseline tests with the OEM condition, meaning we don't touch the vehicle, just prep it. And then what we do is put the dyno valve into the vehicle, and then we do 3 tests while it's considered modified with the dyno valve. And then these tests put the engines under a certain strain. The rollers then rotate, and it puts a resistance against the rear, or front wheel drive, it puts a resistance against the axle and the tires and the engine. So the dyno simulates going up a hill, simulates different driving conditions, windy conditions, and what this does is it actually simulates road conditions, and then when a vehicle is put under a load, it pollutes a lot more under a load than it would just sitting there idling, or just sitting there idling while you accelerate. So what we do is there's a bunch of parameters that come out of this. So as you're testing these vehicles, you get a lot of data, and this data could be then deciphered, and because we have an electronic controller on our device, we could then program and change the program inside the controller to maximize under which operating condition parameters in the computer, so then when the car is on the road, a controller for our dyno valve could react according to the conditions that it was pre-programmed for from this dyno room. This is the shed room. I'll give you a little bit of history. Back in 1994, or 93-94, we were getting the executive order, our first executive order for OBD1, and back then we had a choice of doing 300 cars or do the cleanest and the dirtiest in America, which turned out to be the Ford Taurus, which was a 93 Ford Taurus, which had LEV emissions, which is low emission vehicle. That was for the year 2004, and it had this back in 1993. And it was a very efficient engine. It was 3.0 V6 and got 39.6 miles a gallon, which is unbelievable. It was just the cleanest car, and the Miata was the dirtiest car at that time. 1 year after the Miata came into the country, it wouldn't pass smog. The reason you see those sheds behind me is because back then, actually General Motors, Ford, Chrysler had offices at the state test facilities, and Well, what happened is back then our product was called the Econo valve. It was the mechanical dyno valve. It's come a long way since then. Now it's fully computerized and upgradable through a flashable chip that's on the computer itself. But back then it was mechanical, so it had to be hooked up to every linkage of every vehicle separately, and it was hard to make that work on every vehicle. So we've come a long way since then. But what we did do, since we tested back in '93 with it, we actually took the same vehicle, the '93 Taurus, and got ULEV. Remember, this is back in 1993, and we got ULEV for the year 2020, which is ultra low emission vehicle, which is really just natural gas and propane. And they didn't think that gasoline was going to be around in the year 2020, so maybe it still might not be around, we don't know. But the thing is, on the Horiba equipment, which is the really expensive computers that analyze all the data, they were getting minus zeros on the printouts. So the ERB came in and closed the lab down for 4 days and calibrated the equipment and found out there was nothing wrong with it. So there was a problem because the data was saying that